All right, this problem, example 4, find the zeros of this. This is the purpose of those last two techniques. The possible rational zero theorem and the Descartes Rule of Signs. Those two rules will help us find the zeros of this. And we're also going to use our calculator to assist us. All right. So first off, 3x to the fourth plus 23x cubed plus 56x squared, 52x plus 16 is a polynomial function. The first thing I want to do is Descartes Rule of Signs. So p of x is that, p of negative x is this. It's going to be positive 3x to the fourth minus 23x cubed plus 56x squared minus 52x plus 16. Again, even-powered objects, 3x to the fourth stays the same, 56x squared stays the same, 16 stays the same. Odd-powered objects change sign. Positive becomes negative, positive becomes negative. Looking at p of x, we can see p of x has absolutely no sign change in it whatsoever. So I know immediately there are no positive solutions. No positive roots. Okay. That's really helpful. So when I do my possible rational root list, like we did in example 1, I don't have to put plus or minus, I just have to put minuses, right? Because there are no positive answers. Looking at the second one, plus changes to minus, that's 1. Minus changes to plus is 2. Plus changes to minus 3. Minus to plus 4. So there's 4 sign changes, which means there's either 4, 2, or 0 negative roots. Alright? So I can see right off the bat if there's any rational roots whatsoever, any rational answers, they got to be negative because there's no positive answers. The roots could be imaginary, I can't tell that, but at least I know if there's any roots at all, they're going to be negative. So now, when I do my p over q, I no longer want to look at this function. Because I'm trying to solve p of x. Again, for the sake of Descartes Rule of Signs, that's why p of negative x is there. Once you've got your information from Descartes Rule of Signs, throw out p of negative x, get it off your paper, don't look at it anymore, it causes issues. To do the possible rational roots, the two numbers I need are all the factors of 16 on top, all the factors of 3 on the bottom. So I know p is all the factors of 16. Again, only negative factors do I care about those. So negative 1, negative 2, negative 4, negative 8, negative 16. That's all the numbers divided evenly by 16. And q is all the numbers divided into 3. That'd be 1 and 3. So p over q is just going to be every variation of p over q. So these 5 numbers over 1, these 5 numbers over 3. So the possible rational roots here are going to be minus 1, minus 2, minus 4, minus 8, minus 16, minus 1/3, minus 2/3, minus 4/3, minus 8/3, and minus 16/3. You're going to learn to appreciate problems that say just 1x to the power. So you don't have to get all those fractions, but take what you get. All right, so once you get this list made, what we did with Descartes Rule of Signs was we limited this list down to a half a list, right? Instead of having to check 20 numbers, we only check 10 because there's no positive answers. Again, it's not hard to do it either. That's one reason I like to throw that in there. There's some other rules too that I've thrown out that aren't, they end up costing you more time than they would save you. So they're kind of cool, but why do something that's going to take time away from you? So if I type in my function here, 3x to the fourth, be careful with the caret button, it brings you up top, you got to press the right to get back down, plus 23x cubed, bring yourself back down, plus 56x squared, plus 52x, plus 16. Be very careful you type it in correctly. Okay, once it's typed in correctly, what I've got here is a list of all the possible rational zeros there are, right? So I come over here and start typing those numbers in. Negative 1 equals 0. Negative 2, 0. Negative 4, 0. Negative 8, not 0. Negative 16, so on. All you need is 2. All right? In fact, I got 3, that's a bonus. But whatever the power is, you want to get it down to a second power. So as long as you have 2 answers, 2 zeros, you're good. And again, I've just started putting my list here, right? So what I would do now, I'm assuming that if I kept on going, there's going to be one more of these, like negative 1/3 might work, something's going to work. Is it negative 1/3?
It's 2/3.
Negative 2/3? So you can find all 4 zeros. So right there, you got your answer, right? But let's just assume that we're going to get, let's say, negative 1, negative 2, and then the other two answers are 7 plus or minus the square root of 17 over 9. something like that. So let's just say that we're getting this problem that doesn't get all the zeros on our list. Okay, they aren't all rational. So what I want you to see here is we know for a fact that these two guys work here, right? -1 and -2 both work. All right, and we'll pretend we don't know anything else about anything. All right, so what I'm going to do at this point is I'm going to do synthetic division to reduce the polynomial. So P of x, I'm putting a root of -1 into it. I should get a remainder of 0 because it's a root. I'm going to put 3x to the 4th, 23x cubed, 56x squared, 52x, and 16 as my polynomial. Putting in 0 terms as necessary if there's any powers missing, which there aren't, so I don't have to worry about that here. I perform one synthetic division with an answer that works, so again, I know I'm getting 0 here, so I should, if I don't get 0, I messed up, all right? 3 gets brought straight down, -1 times 3 is -3, 23 and -3 make 20, times -1 is -20, added to 56 makes 36, times -1 makes -36, plus 52 makes 16, times -1 makes -16, we get a remainder of 0. Then, I take my second 0 that I found, -2, and do synthetic division again, to here. So now we got 3x cubed plus 20x squared plus 36x plus 16 is my polynomial. I've reduced the main one down to a cubic. I'm going to reduce the next one down to a quadratic. Bring the 3 straight down. -2 times 3 is -6 plus 20 is 14. Times -2 is -28 plus 36 is 8. Times -2 is -16 plus 16 is 0. Remainder is 0, right? That gets me down to a reduced polynomial now of 3x squared plus 14x plus 8. Now the quadratic formula can be used because we're trying to find that equal to 0. Once you reduce your polynomial down. So when I start writing my answers, x equals -1, -2, the answer is already found right here, along with whatever the answers are to this, which if we were to do the quadratic formula, here's our structure. Minus b goes here, 2a goes here, b squared minus 4 times a times c makes 196 minus, looks like 96, right? Which is 100. 10, so -14 plus 10 is -4 over 6. -14 minus -10 is, or minus 10 is -24 over 6. That gets me -2/3 and -4, the other two answers. So again, if the calculator table gets you all the answers, fine, write them down, that's fine, no problem. But again, if this was the square root of 17, those are the other two answers. And they're not counted as rational answers because they're not rational. So again, this list is all rational answers possible, but it's not necessarily rational answers you can get. They're going to give you enough rational answers, though, that you can reduce the polynomial down to a quadratic every time. Okay? So they'll give you that much information. If there's not enough information, they're going to give you something else to enable to get it down. But every problem should be able to be reduced down. Let me just throw one extra thing in here. If I tested all 10 of these numbers, only found 1 0, it probably happens multiple times. So let's say -1 worked, but the rest of them didn't. Do -1 here, do -1 again. It probably works twice. It'd be like one of those x minus or x plus 1s to the second power or third power, something like that. So if you get a long list and only one number works, do it once, do it a second time. If it's the fifth power, do it a third time. Keep going until you get down to a second power. Polynomial, quadratic formula, or factoring works from that point.